Hello everybody, welcome. Welcome at this presentation where we are going to talk about machining strategies, which is a bit of old news perhaps, but machining strategies in small batch production, which is perhaps a little bit different. And I have to warn you up front, from a presentation perspective, the presentation, the slides you see behind me, they are uh, trespassing quite a lot of rules. There are much too many bullet points. There is quite a lot of text. So stay with me, and I'm well aware of that on the slides there's quite a lot of information. But I did it a bit on purpose because as that the presentation can serve also as a reference guide for you afterwards. If we talk about small batch production and machining strategies, first of all, perhaps I should clarify a little bit machining strategies, because in machining, when we talk about strategies, we all know that, of course, for 80% it's milling strategies, because when it comes to turning applications or drilling or boring or reaming and so on, the strategy part is rather limited. Is perhaps turning specialists now are going to not like me, I suppose, but it's a rather limited thing. While in milling, it's a very enlarged thing when you start talking about strategies which are methods on how are we going to do something now. But machining from a legacy perspective comes kind of from mass production, and today we are in a situation where a new reality is emerging, or is already there, and that's the reality of small batch. And if we think on small batch, what is small batch in comparison with mass production? It's quite a lot of different work pieces. Every work piece needs to be produced in a small amount of pieces. That means that people in a workshop or in the programming or in the engineering department all the time are confronted with changing, modifying reality elements. And that means that if you look to the total picture, we kind of have a different situation from mass production. Mass production, where once production is on, it's the main task for people working there is to make sure it continues to run, but there are no modifications or things to be done. While if we talk about small batch production, it's very much the opposite, and that's why we started to ask the question, if we look to machining strategies now, is there a difference related to if it's mass production or small batch production? And the answer to it is absolutely. There's a very big difference. And that's in an hour, which is very short. We want to draw your attention to a number of things. Now, the underlying model I always use for this type of presentations is a machining process concept, where we say machining is a physical process where we form workpieces by removing material from it. And in doing so, this process, there's lots of things, lots of phenomena taking place. You have the mechanical side, thermodynamics, and so on. And we have to make sure that all these things are in balance with each other. And balancing these means that all the variable elements in it, we need to understand how they interact, how they influence the process, and make sure there is a balance. And to make that happen, what we need is, I call it the knowledge side. We need knowledge of the process, we need experience, we need expertise, and so on. And all of that we need to put there so we can create the balance we want. And in such a process, we also need, of course, metrics. We need to measure how good we are in balancing this process. So we need metrics to measure. And on the metrics here, I'm going to talk several times today on how we can use certain elements to see, to measure, to evaluate what is going on. And if we do all of this, machining leads to the wanted result. The wanted result, which is kind of a multidimensional thing. The wanted result is quality of the finished workpieces, of course. But the wanted result is also economic, because machining is a very nice thing from a technological perspective. It's very exciting to work with this from a technological or scientific perspective. But we should not forget that in reality, in the industry, people do machining in their production with an economical perspective. They want to make some profit. They want to have happy customers that are happy with the delivery times which were promised and so on. And there is, of course, also with one umbrella word, the sustainability side of it. And today we are going to spend quite some time to it, because I think if we dive into machining strategies, what are the differences between mass production, small batch production, that it's mainly in the sustainability dimension we see big differences, and we have to anticipate on that. Now, if we talk about machining, where we want to produce high quality workpieces at an acceptable cost/price for the customer. We want to keep our customers happy, meaning that we deliver in time, we deliver the wanted quality and quantity and stuff like that. There are things we have to make to work together. There is the strategy side. How are we going to do something? There is the tool side. Which tools are we going to use for that? There is the machining data side of it. How are we going to use the tools in the application? And there is the human side, the intelligence side, because somebody needs to put things together in a working order. And this is, if you look back the previous events we have been talking about tooling in this perspective. We have been talking about machining data, and today we want to talk with you about the strategic side, the method side, the machining strategy side of it, to create a full picture as much as possible. I'm of course not alone. I'm together with two lovely colleagues that are helping to make this possible. Because, as I always say, for me, this is big fun. I like to talk about machining, but there is the hard part of making all of this happen from a technological perspective, and that the two ladies are taking care of, Alesia and Margarita. The agenda of today, there is a first part which we are going to walk through very, very fast. That's the technical side, the technological side, if we talk about strategies. But that has been discussed so often that here I just want to bring in mind some basic stuff again. I want to focus mainly today on, if we talk about machining strategies, the economic dimension of it and the sustainability dimension of it. Because that's where we are going to see big differences between mass production and small batch production. Now, small batch production, I already said, it's fundamentally different from mass production, because you are confronted in a very short time with a lot of different situations, different workpieces, different quantities, different requirements, different quality stuff, different workpiece materials, and so on. And that means that, for instance, in mass production, if you need an hour to prepare the machine, let's say you need an hour to prepare the machine and you have to produce 60 workpieces, that means that 1 hour setup time you can spread out over 60 workpieces. And in the total production time per workpiece, you need to include 1 minute setup time. Now, if for some reason the customer says, wait a second, I don't need 60 workpieces, I need one. But still, you need 1 hour to set up the machine. The time you need to set up the machine is independent and not depending from the batch size. So you still need an hour. But now that hour has to be carried by only one workpiece. And that creates a completely different situation, where in mass production, setup time in machining, it's important, but it's not a crucial factor. In small batch production, it's a very important factor. And one of the elements we are going to take into account if we decide which strategy is best to be used is the impact of the strategy we use on the setup time. Because some strategies will demand more setup time than others. And that goes for all the other stuff, downtimes, unexpected downtimes, scrapped workpieces due to bad quality, total tool life impact, and so on. It's all very different compared to mass production. And last but not least, errors, mistakes. If you destroy a workpiece, if your total batch is 1,000 workpieces, you lose 1 out of 1,000. If you need to produce only one workpiece and you kill it, you destroy it, you lose everything. You can restart. And restart means the same costs again, the same time again. Trust me, your customer will not be happy. Some people take care of it and they say, yeah, but wait a second. To minimize the risk, if the customer needs one, we will produce two. If we lose one, we still have one. Yeah, but the finance manager in the company will not like that, because if you do that for a whole year, that means that by the end of the year, you have an enormous stock of security workpieces, which has cost a lot of money and time in production, and they are lying there doing nothing. So the finance people will say, "What are you doing?" So it's a tricky thing, small batch production. Now, if we talk about tool selection for small batches, if we talk about tool selection, there's always that dilemma, because tool selection and machining strategy, the question is, which one is the driver? Is it the selected machining strategy that decides which tools to use, or is it the selected tools that will tell you which strategies are possible? And in mass production, people take it the pragmatic way. They say, we start doing testing. We make combinations and we see in the end which one serves best. In small batch production, that's not possible. Well, it's possible, but it's not justified from an economical perspective. You can't test for a week to produce one workpiece. Huh? So you need to make a decision up front before you start machining. And a key question you are going to confront it with is, if we have already tools in the workshop, see all the previous workpieces we made, should we reuse those tools and modify the strategy? Should we say, okay, we already have a whole range of high feed cutters, high feed milling cutters, and the next workpiece we think high speed would be the best? Should we say, no, forget about high speed because we have high feed cutters and we use the high feed cutters and we modify our strategy? Is that what we do or not? Do we say, no, we need high speed, so we need another set of tools. We need to buy another set of tools again. That's in small batch production, if you talk about tool selection, and again, I'm not going to make friends here, but I don't think you could leave this to technical people, because technical people are much too much in love with machining, the technical side of it. It's rather more management thing here. Should we maximize the use of existing tools already, or should we invest in new tools? With other words, should we go for flexibility if we do tool selection, or should we go for efficiency? And if we try to put some criteria together for new tool selection, it's about versatility. That if you go for flexibility, you need versatile tools. And people say, yeah, but versatile tools, situation by situation, they are, from a technical perspective, better solutions, perhaps, because then you put the process cost efficiency on the table. I want to do workpiece by workpiece efficient machining, cost efficient, time efficient, quality, whatever efficient. Yeah, it's okay for me. But then you have the other question popping up. Yeah, but if you have a very efficient tool with a tool life of 2 hours, and you only needed 10 minutes to produce that one workpiece, what are you going to do with the remaining tool life, the total tool life utilization? That is then a thing. And it's not only for tooling. The same question goes up with setups, workpiece holding, and so on. Should we go for flexible systems, or should we go for efficient systems? And reconditioning and reusage of tools in small batch production, I think, is a very important thing. Because in mass production, very often people exploit the possibilities of the tools to 120% already. And then, yeah, is there something left for reconditioning is the big question then. While in small batch production, it's a completely different situation. I have seen tool cribs, tool where they keep the tools, where 90% of the tools kept are still very capable of being used in another workpiece. The tricky part is nobody knows to how much. People say, yeah, of course you can still cut with it, but if you ask the question, how long? I don't know. Yeah, and that I don't know, there you have an issue then, because, yeah, who dares to take a tool, start using it if you are not sure it's going to do the full job? Think on what happens if the tool fails. Broken tools, but also destroyed workpieces. So I think in small batch production, and the time is much too short to go in details here, but in small batch production, if you put everything on the table, all the different things that are important in production, that in 90% of the cases, and everything depends on how you did before, but in 90% of the cases, the best approach is to say, okay, I have here my set of tooling, and it can be cutting tools, but it can also clamping tools, measuring tools, whatever equipment you have around the machines. And I optimize the process around the tools. I said, this is the tool, that's it. Now, to produce a workpiece, which strategy, which cutting conditions, which cutting data would I or should I use to make sure this tool does the job? In that respect also, CAM simulations, I would urge you to do even more CAM simulations in small batch production than in mass production. And that's a misconception. People sometimes think if I need to do a big number of workpieces, I should spend the needed time on preparing, on CAM and simulating, and that's correct. But in small batch production, it's even more important to do that. Because in small batch production, if you fail on the first workpiece and you need only one workpiece, you are into a demolition course with your customer. Huh? So it's so important, that CAM simulation part. If you invest in new tooling, because you can't run the same tools forever, now and then you have to challenge the tools you have in a workshop and ask yourself, is this still what is best available for me? And make sure you use a full vision decision-making framework. Not select a tool which is best for one workpiece, but look to the total return on investment for a certain tool over a number of different workpieces, over a certain time, over a different number of machines, and so on. Count on knowledge which is in the company available. Your operators, they know quite a lot about which tool is working, which tool is less working, because they are daily confronted with it. And of course, in today's world, with all the possibilities we have, it's only an hour ago I had a discussion here with a colleague, and where I said, yeah, in the past we knew it, but from a practical perspective, it was impossible. Today, with all the digital possibilities we have, come on, put the data together and see if you can recognize some trends in it. Small batch production, the main thing is that you have to find a good balance between universality, adaptability, flexibility, versatility, all the different words for it that you have with a limited amount of equipment and as big range or range as possible for workpieces you can produce. And that adaptability you should find in the tool set you use in the workshop. And optimizing the available tools, that's what you do through the strategy selection then and the cutting data selection. And I think in small batch production, it's this balancing that is the core on which we have to base our decisions about which strategy to use, but strategy then defined beyond the cutting edge. And I'm going to come back to what I mean with that. Now, if we talk about strategies very quickly, it's a strategy is a scenario we could use. It's a technical scenario originally, which we could use to finish a certain workpiece, to do a certain operation, to finish a whole batch of workpieces, whatever. And it starts from what are the targets in the company? And those targets, they drive all the rest. They drive the CAM programming, they should drive tool selection, they drive cutting condition selection, and so on. And it all links together. Strangely enough, it's a remark I want to put here. You know that so often in a workshop I see just the opposite. People start with, I like high-speed machining. So people already have a high cutting speed in mind. And then they look, yeah, but a high cutting speed, I need good cooling. Cooling is important. That's the cutting conditions. And then they say, yeah, but for a high speed operation, I need a high speed cutter. So the tool type is defined. And a high speed cutter, you have to be careful how you move it. So suddenly the tool part generation, the CAM part is decided. And then they say, and you know what? It's cheap. And then I think, wait a second, you are going the opposite way. You should start by defining, I want a cost efficient approach, and that should drive all the others, not the way around. Talking about strategies, there are families of strategies. Geometrical strategies is about how do I move the tool. Technological strategies is about the machining process, which core technology do I use or do I want to use? You have the application strategies. Application strategies are connected to tool types. Face milling, square shoulder milling, slot milling, all of that is application strategies. And you also have, the best I can come up with, hybrid strategies. Hybrid is where I'm confronted with a certain typical feature I need to machine, a thin wall, a thin button, or whatever. And then to handle that from a quality perspective, I don't only want to produce a thin wall, but a good thin wall. I start to combine partly geometry, partly technology, partly application to figure out how I can do best to come up with that finished feature, a thin wall I need. That's hybrid. Which is best? I'm not going to spend time on it because at previous occasions, at previous Getting Technical events, we have been spending quite a lot of time on the technical side, the technological side, the scientific side sometimes about machining strategies, which one, where, how, what, and so on. So if you are interested in that, I would urge you to look at previous recordings of events. One I want to put a little bit extra in the picture is that so-called high feed machining, or some people more refer to it as set level machining. It's kind of, here you have a typical example. The strategy is deciding the tool, or the tool is deciding the strategy, whatever. It's the two together. High feed, I think, as in the light of what we said before, what is important in small batch: versatility, flexibility, reliability. That are a bit the keywords. I think if you put those up front, that very often you end up at high feed machining. High feed machining is offering quite a number of advantages in that situation where we go for universality, flexibility, and so on. High feed machining is relatively seen a very efficient machining system. I mean, if you look to the pure machining, very often it does the job faster if you include setup and so on, then other machining approaches, which makes it very often the most economical. Also from a tool life total tool life optimization part. First of all, high feed machining is a very smooth machining process compared with others. Right? It's not so aggressive. That means that tool life itself will show a tendency to be longer. On the other hand, if you have a high feed machine, a high feed cutter, that you can use in different applications, all the same cutter, what you end up with is a longer or a bigger total tool life, which makes double up. That this is, from a tool life perspective, a good approach. It's as it is a smooth cutting. It's very nice in difficult applications. I think in typical difficult materials and so on. It allows you to do roughing without high demands on the environment. I mean, the technological environment, it's smooth cutting. There are no vibration or lesser vibrations. There's higher stability. So from a workpiece fixturing perspective, from a machine stability perspective, it's less demanding. And it makes things smoother. It gives you higher process security. A high feed cutter is a rather forgiving cutter. And also, to remove a certain volume of material, the power you need is relatively low. That means, and yeah, if you look to the workshop, typical workshops for small batch machining, you don't find the big monster machines there. It's medium-sized machines, small machines, and in such a situation where you have some serious machine limitations to take care of, and on the other hand, still you want to go fast, high feed machining is a very interesting approach. I took high feed machining here as an example on how you could start arguing, discussing in what would be in a certain workshop a good tooling family to start using as the standardized tooling for small batches. It's lesser than, what is the tool life and what is the cutting speed and stuff like that. It's more about a general picture you try to create. How much can I do with a certain type of cutter, and look to the broader perspective. Small batch, from a technological perspective also, don't use aggressive strategies, I would say. Aggressive strategies, I mean high performance, high speed, all that type of stuff. It's all very nice, but it's rather aggressive, meaning that to make it happen, the demands on the environment, the machine, the fixturing, the setup, and so on are rather high. And if you can't make it, you are in for some serious trouble. Avoid aggressive strategies. Think more in terms of stability, predictability. That is much more important, looking to the broader picture, than that aggressive one operation, one solution type of approach. Setups, enlarge your view a little bit, and see if you can, by modifying strategies and tooling, if you kind of can optimize, and in this case it means minimum time needed. If you can optimize your setups, if you use always the same type of tooling, the part of the setup time where the tools needs to be set up is cancelled. And that's already a big gain in a number of cases. I already drew your attention on simulation and validation before start cutting, and it's very strange. People are well aware of the importance of this in mass production, but in small batch production, for some, I have an idea why. Because people are always hurrying up, fast, fast, fast. The customer is waiting. This, that, and they start to do take the wrong direction. They say, we don't need simulation. We see on the machine what happens. Yeah, it could be, but if what happens on the machine is a catastrophe, you have a big problem. Huh? It's better to spend 10 minutes on simulation before you start doing machining, just to make sure. Work holding. Because traditional, if you leave people a free hand, they say, yeah, I clamp my workpiece somewhere on the machine table. And then I start to do zero setting and I modify my program and stuff. It's taking time. Why not that's 0 point clamping? Then you always know where the 0 point is, and you don't need to do the zero setting routines each setup. Of course, people say, yeah, but do you know what it costs 0 point clamping? Yeah, I know what it costs when you buy it. But I also know what it costs 1 minute loss in production time because you need to do each time again zero setting. One minute per batch, and if you have to do thousands of batches every year, yeah, you can calculate yourself. Huh? Real-time monitoring, keep your eyes on the process. And I mean, or the operator, or the more modern approach with sensors or whatever, but keep your eyes on the process, keep monitoring the process. So in case of you are there to correct, to modify, to avoid that something ends into a catastrophe, and make sure there are feedback loops. What you learn in this workpiece, you should make sure that you inform all your colleagues in engineering, in program, perhaps even management. Because management makes the pricing to the customers, and if you end up with a big problem with whatever, you should inform management about that so that next time they can take that into account. Um, Also, feedback loops between different batches. What I learned from this batch, I should take into account for the next batch. In that respect, you have conventional approaches or conventional machining approaches where people say, okay, you know what, I have one tool, one set of cutting conditions, one workpiece material, that's it, and everything is kind of fixed. Contrary or opposite to that is what is called adaptive machining. Adaptive machining is I constantly modify, adapt things in the process related to the actual situation taking place. That's called adaptive machining. People connect it to sensor techniques and stuff. But if you have a good operator, adaptive machining is in reach. If you give the operator the freedom to do his job seriously. Adaptive machining, I think, is most interesting in small batch production, much more than conventional machining. And conventional, no misunderstandings. With conventional, I don't mean a conventional milling machine. Both can be CNC machines. My word conventional is one cutter, one set of cutting conditions, and I don't change that. Adaptive means I have one cutter, but cutting conditions I modify even in process depending on what's going on. Key for that is that you have a well-equipped machine with sensor technique, or that you have a well-skilled operator at your disposal. And looking to tools like that, I would like to urge you, soon Seco is organizing a webinar on face milling applications. You recognize face milling is a certain strategy. We call it an application strategy. And they use the word well balanced. Well, I would invite you to this seminar, and you should look with different eyes now. Don't look for cutting speeds and stuff, but look for how can I come to a good combination of an application, a range of tools, or one tool, I don't know, a set of cutting conditions with a window of adaptability that I can share. And do your evaluation like this, and don't each time again when you have a new batch think that you need a new milling cutter and stuff like that. Some economical thoughts when we talk about machining strategies. Very often people like to talk about cost per part. I suppose a number of you know what cost per part is. It's about efficiency. Well, I would like you to forget that cost per part from a machining efficiency perspective, but look more to something from a process stability and quality perspective. You don't want to produce one workpiece, one batch in the best possible way and destroy all the others. No, you want to do all to be good. by running stable machining processes. And that per part it costs a little bit more. Who cares? Because we see that in the end, the machining cost is neglectable small in small batch production. Uh, think in terms of if you minimize tool changes, if you can minimize tool indexing, if you can minimize setups, how much money you can save in terms of that you create extra machining capacity. Because if instead of spending 1 hour in setup, you spend only 30 minutes, that gives you 30 minutes extra capacity to actually produce workpieces. That's also a cost thinking. Think on total tool life, not tool life per workpiece, tool life per application, but take the tool up front and say this tool has a full capacity of, I don't know, 2 hours machining. How can I use it as such over different batches of workpieces so that I reach the 2 hours cutting? Instead of after one batch saying, the tool is up to 60% is used, I don't throw it away and I take a new one for the next batch. That's a waste of money. And you have the energy consumption thing. Energy costs money. In machining, a lot of people talk about the labor costs and tools which are expensive. And still today, I have a feeling that the energy thing it's a bit neglected. But I would say next time you have the opportunity, check on the electricity bill for the workshop. You could be in for a surprise. Digitalization plays an important role. I think it's very strange for me. It's a strange thing, because come and artificial intelligence and digitalization is really showing all its possibilities, all its potential in small batch production. While if I talk to people, they say, no, all that digital stuff, that's for mass production. That's not for us. I don't agree with that. I think the smaller the batch, the more you should try to exploit the possibilities we have with digital techniques. Come, uh, programming time, simulation, all that type of things. We should really exploit it to the maximum. If there is a possibility, start working with digital twin technology. That's the summum of simulation technique. There you have, or you could start dreaming about in-process live simulation while machining, real-time data, artificial intelligence to recognize trends and so on. It's all things which I think are very important. While we have that fully in operation, it's still the operators we have to rely on, and a knowledgeable, well-trained, well-skilled, motivated operator. He can do things which are today not yet possible digital. They can pick up signals that indicate that the process is going in a certain direction, perhaps a direction we don't want to. He can optimize parameters, data, depending on what he hears, what he sees. And he, if he's motivated enough, can be very effective in communicating his experiences with the programmers and the engineers about how things are going. And as I said, feedback loops should not only be between people, it should also in between batches of workpieces. What I learned from one batch, I should take with me to the next batch. Artificial intelligence can help in the future. In the meantime, because sometimes people are sitting there, it's not for me. Could be today, but then today you still have the opportunities of working with what people call SOPs, standardized operating procedures, where you put your knowledge, your expertise in a structured shape and make it available for other people, so that the knowledge which is in the company is spread more in a wider network of people. Sustainability, a loaded word. Everybody is into sustainability. Still a lot of discussions, still a lot of interpretations. For me, sustainability, if I think on it, sustainability, one could say in a very general way, is doing what needs to be done today without jeopardizing the future. What I mean with that is, it's today I need workpieces, or my customers needs workpieces. So I should focus in such a way that today I do what is needed to give my customers what they are demanding for. Quality workpieces in the correct quantities, in the correct time. That's my short-term objective. But I should do that in such a way that also next week, next month, next year, 10 years from now, I'm still able to do that for my customers. For me, that is sustainability. And that means that sustainability goes far beyond the environment only, which for a lot of people is what they translate it to. Sustainability is an economic responsibility. It's a technological responsibility. It's a responsibility to the planet, of course. It's a responsibility to your customers. There's so many dimensions in the word sustainability. Anyway, we could say, okay, without that multitude of things, we can select some. One is energy consumption. And I selected those who have in common something which I think would be interesting, because for a lot of people, they say, yeah, it's all very well sustainability, but sustainability is contradictory to efficiency. That's in the head of people. They say, ooh, sustainability costs a lot of money, takes time, extra routines, or they say, it's going to jeopardize my efficiency. No, it doesn't. And I tried to come up with some examples where if you focus on sustainability, you see that you have a bonus. And the bonus is that very often going this way gives you a higher cost efficiency or time efficiency. So don't say it's opposite. It's reinforcing itself. If you reduce your energy consumption for the noble cause of the planet, for the less noble cause of your finance things, less energy is a lower electricity bill. So it's the same thing, you know. Don't blame sustainability all the time. It's going to help you a lot if you play it right. Process optimization. Make sure you select the strategies that gives you the lowest energy consumption. Make sure that your machines are not standing still. Because if your machines are standing still, I gave this example at the previous Getting Technical event. If your machines are standing still, from an economical perspective, they don't do anything. They don't produce workpieces, and it's the workpieces with which you earn your money. So when they are standing still, they cost. They bring you no advantages, but they do cost energy. They consume electricity. So process optimization. The process itself should consume the lowest energy possible per whatever unit you want to measure it. But you should make sure that your machines are running all the time. Your machine selection in that respect is very important. Your machine utilization is very important in that respect. If you look to machines today, there are so many possibilities, where you have energy recovery or energy reduction. When you are slowing down the machine, it's a little bit like electric cars, you can take part of the energy there and transform it back. Use renewable energy. The 2, the 3 last ones here, I think you all are aware of, but also the first one, strategy selection, tooling selection, cutting data selection, is a big source of energy reduction. And energy reduction is good for your wallet and it's good for the planet. Resource utilization, waste which is generated, material costs and so on is another thing. Here we talk about resource utilization. You have material utilization strategies. Already 30 years ago, we talked about near net shape machining, where we said removing a lot of material in roughing, that takes time, it takes energy, and it's wasting material. So we should look to that. Raw workpiece materials, how are they? Which shape, which form do I need to remove a lot of material? Uh, are there possibilities for recycling, reusage by recycling the ships, by recycling used tools, by whatever? It's all doable nowadays. And of course, advanced tooling selection. I mean with that, go back a couple of slides where I said, if you look to tooling for small batch, perhaps tool life, total tool life is much more important than the tool life per application. With other words, how can I use my tools? How should I select my tools so that the full potential available in the cutting edge on tool life, usable lifetime, is fully used, and that I don't throw away 30-40% of the capacity. And people say, yeah, but I recycle. I say, so what? You still throw away 40% of the capacity. Uh, Efficient resource utilization. Waste. Machining is an operation where, unfortunately, it's part of the technology. There is waste, there is coolant and lubrication. After a while, it needs to be taken out. And I know it's recycled and so on, but still it is waste. And one could ask the question, are there possibilities to perhaps, in the end, cancel it completely? It's worthwhile asking the question. Huh? And people say, yeah, but wait, if I leave the cooling out, my tool life is going to be shorter. Yeah, I agree. But remember, today you throw away your tools only 60% use, you have 40% capacity left. Now, that 40% capacity can handle the 10-15% loss in tool life you have because you take the coolant out. Look to the broader picture is what I try to say here. Ships, swarf, uh, easily recyclable nowadays. There are all kinds of techniques where people can handle ships and reuse them in afterwards. And there is the part of sustainable product design. I put this a little bit vague because if you are in a workshop and you need to produce a workpiece, most of the time there, especially small batches, there is no time left to start discussing the design of the part. So this is a bit theory, but it could be. A big source of pollution in machining is air pollution. Uh, Filtration techniques and stuff are important in that respect. Green coolants, green lubricants are available. Investigate what it could give you, what it could bring you. I didn't know exactly where to put this, but logistics, supply chains optimization to minimize transportation and so on. Also intra-company. Make sure the layout is as such that the workpieces aren't traveling all the time somewhere in the workshop between machines, because also that is creating pollution. Life cycle based approaches. You can life cycle analysis for the total process, or you can do it in a little bit narrower scale for total tool life. How to handle tools so that the full potential available is exploited over different batches. Circular economy principles. There are some interesting principles in that so-called circular economy, and people always think circular economy. I mean, externally, me with my suppliers, me with my customers, and how can we do? But also in a workshop, in one company, we can, do circular things. And a personal example I know from my own professional work, in a company, it's tons of paper which are used in printers. and the lifetime of such a paper is perhaps 10 minutes or some, because somebody needs to check a drawing or something, and then they throw it away, and the backside of the paper is unused. You grasp my idea behind this? If you fully could, yeah, your paper consumption in your company is split in half. That's intra company circular economy. That's ridiculous. Yeah, is it? uh, Workplace safety, your people, you also have a responsibility there. The operator well-being, from where do you source your materials? Are your suppliers respecting their people in what they do? Safety, it's not only well-being, but it also is it safe in certain circumstances. Now, I know a workplace is a workplace. 100% safety is you can dream, but yeah, okay. But at least you can aim to go in the good direction. There are all kinds of regulations available to help us there. I'm not a big fan of regulations, but sometimes they give good guidance. Um so these are a few examples of what I call sustainable machining strategies. And it goes beyond the pure process, and it puts the process in the broader context of the company, of the workshop. Now, implementing these, yeah, take the advantage or take full profit of existing technology today. Additive manufacturing. Why is additive manufacturing so interesting? Because it can deliver you workpieces which are near net shaped. The very old idea. So the waste of material, workpiece material, is a lot lower. Digital possibilities, Internet of Things, digital twins, all of that will help you to not waste too much time on trouble and so on. Circular economy principles will help us. So technologies are available, and also hardware kind of tools, lubricants, cooling. It's all there. It's just, yeah, make use of it. The benefits, yeah, it's environmental, the planet, but there are also economic advantages, as I already told you. Makes Be aware of that it goes two sides. If you start working with this, it gives you social benefits, it gives you workplace benefits. I mean, for people, it's yeah, technological innovation, because everybody is after innovation. And sometimes then I think, yeah, innovate. Where is the innovation in machining nowadays? In new cutting tools? No, not really. Uh, that's a very mature thing, but it's more in how things are used, selected. That is where the innovation still is. Uh, and there are challenges. I know if you start thinking about that, the first one everybody comes up with, yeah, but it's expensive. There is investments to be made, but that is part of any company management's targets, or tasks. Yeah, investments. Look into investments that needs to be done. There is process transition. Yeah, we always did it like that. Why should we do it different now? Yeah, yeah. Why should we do it different? Uh, there's always what I started with, that thinking, yeah, but if I prioritize sustainability, I'm going to lose productivity. No, no, no. And you know, all of this, in the end, it's people that make the difference. It's people that will drive this whole thing. But to make sure that people are on your side, you have to make sure that they have the correct education, that you communicate with your people about why are we doing this, what is the target, what is the purpose. Involve people from the beginning. Don't confront them with a given thing and then that's it. Yeah. Make it practical. It's all very nice to have discussions in boardrooms, but in the end, yeah, you have to leave the boardroom, go to the shop floor, and start doing things. Make sure it aligns with your KPIs. And it's not a big problem to align it, because I hope I at least made you doubt now a little bit. Yeah, perhaps sustainability will help us. And I know there are initial investments, but it will help us to reduce our costs, to increase our productivity. It's a bit also a culture shift. I think it's lesser yeah, a technology thing. It's more a cultural thing, and it's people that will help us mostly. Some conclusions. Uh, it's all about bringing environmental responsibility, economic efficiency, and technological innovation together. And those three together, that's now my new definition of machining strategies in small batches. Uh, it's about, as example, setup. What can we do to reduce setup? Minor standstills. People call it, or people specialized in production organization. If you talk with them about machine utilization, there's always a chapter, minor standstills. Minor standstills. Minor means small. If you dive in, you could see in small batch production that's minor standstills end up to be 30-40% of the time. That makes them major profit killers, huh? Those minor standstills. And in whatever you do, I think it's important to realize that precision is a non-negotiable factor. You can't deliver to your customers workpieces which are nearly good. They must be good. Invest in tooling, invest in learning, optimize workflows, adapt and refine strategies. That is what we have been talking about here. And you know, if you want to learn more, there are pocket guides available, where you find quite a lot of practical things, how to do, what not to do, where to focus on, and so on. If you are interested, let me know. I send you information about it. Lots of bullet points, lots of text. I told you so. But I hope the story, that I could have your attention and that you were not reading all the time on the text behind my back. Because if you want to have a copy of this, please let us know. We make sure you have a copy. There also exists an extended version even of this presentation. Just let us know what we can help you with, and we see how to help you. Let's, before we close now, check if there are some questions where we have very little time. There is a question here. Yeah, I'm reading from the screen. What are more flexible coatings in milling if you have often different materials to work? That's a tricky one. I would say from a coat, you can't see a coating independent from a geometry and a substrate material. So if I need to answer the question, what is a flexible coating? Yeah, I can't really give you an answer, and I have to look on the time without starting to talk about a geometry and a substrate. Let me put it like this. If you have a geometry which is strong, which resists heavily against deformation, shipping, breaking out, from a geometrical perspective, if you have such a geometry, and if you have a substrate that is capable of handling big temperature differences without losing its support function too much, the best or the most flexible coating, flexible combined with most probably the best performing coating, is the hardest coating you can find. But you hear in my answer that I talk with if and if and if. Because if you say, yeah, and what if the geometry is not strong? And what if the if the substrate is not having that possibility to support maximum, yeah, then you have to go step back in your coatings and go to, and this is very irrelevant to call it like that, but you should go for more tougher coatings. But yeah, tougher coatings don't really exist. A coating is always hard. Indeed, a very difficult question. Is it okay if I come back later? I try to find some more consistent materials here to give a serious answer to this. But it is a difficult question. I'm already over time. Okay, I take one question more. Is it easier to handle universal tools than dedicated tools? I think the one asking the question means that universal is a versatile tool, one tool, broad application domain. My interpretation now is like that. And a dedicated, I think you mean a high performing tool, a specific tool for one application that performs best in that application, if we call that a dedicated tool then. No, I would say a versatile tool is not difficult, but a versatile tool is more difficult to handle because one tool can be used with different sets of cutting conditions, cutting data, when it's used in different applications. That means it's more demanding from the operator, the engineer, the programmer side, because he or she needs to say, okay, I have one tool, but I need to recognize the situation in which I use it and make sure I modify the working conditions, the cutting data, cutting conditions, as such that that same cutting tool is now working in a different situation also. A situation which you don't have with a dedicated tool, with a high-performing tool. Yeah, but it's easier anyway, because a high-performing tool you only use in one application after all. So it's a more fixed situation. All the other questions, because I see here on the clock we are already over time. All the other questions I take care of in the comments. I answer them there. I hope it made some sense. That very short story about a very big or huge subject. Mainly what I try to say is, in small batch production, if you talk about machining strategies, you have to go beyond the cutting edge. It's not just the tool, it's the tool in a given environment, a batch size, an available delivery time, that type of thing. And you have to have a broader look. That's what I try to say. Opposite to what managers always say, focus. Here I would say, don't focus. Keep a broad sight on things. I hope it was interesting. If you want more information, please let us know. As I said, there is you can have a copy of the presentation. There are the pocket guides and so on. And I have one last question. I don't know. It's a bit for me to check how much you look to the text or not. One image in this presentation is mirrored. Did you see it? If not, this thing is available. You should have again a look and try to find the mirrored picture. Let me know what you think is the mirrored picture, and if you have it correct, I send you one of the pocket guides so you can have a look at what those or how those can help you also. Thank you very much. On behalf of my two colleagues and myself, we hope you had a pleasant hour together with us, and we would like to invite you to the next presentation where all the previous ones and this one comes together, and where we are going to check how to make it happen that we make efficiency and sustainability coexist together so we can maximize profits. And profit isn't a dirty word. Even a machining company, in the end, it's about making money. If you are interested in learning how to create that coexistence, most welcome, and we talk to you then.